Assalamualaikum warahmatullahi wabarakatuh. We are Group 16 for Service Learning Assignment for Communication Principle for Dr. Omar bin Abdul Aziz, entitled with Amplitude Modulation AM. So these are our group members. So the first one is Akilesh Nair, Lau Shahwan, me, Muhammad Akmal, and Nur Lara Amin. So for introduction, what is modulation? Modulation is a message signal transformation to a format suitable for transmission through a medium. Or another word is the modulating signal modulates the carrier to produce transmitted signal, which is modulated signal. So next, benefit of modulation. What is the benefit of modulation? Why we use modulation? So the first one is modulation allows the use of multiplexing, allowing simultaneous communication by multiple users at the same channel. For example, radio frequency spectrum must be shared and is allow users to separate themselves into bands. So for the second one is provide controlling over noise or interference by trade-off between bandwidth and noise. So amplitude modulation, change in amplitude of the carrier according to the modulating signal. There are many variants of AM signal. We have double sideband full carrier, suppressed carrier, single sideband suppressed carrier, and vestigial sideband. So this is our equation for AM modulated signal. And then for the sidebands for AM, each sideband is equal in bandwidth, but amplitude modulation is inefficient in terms of power usage. Approximately 2 of 3 of power is concentrated in carrier signal. Carries no useful information. So for the next one is demodulation. Demodulation is the process of recovering the modulating signal which happens at the receiver. Demodulation performed by the demodulation circuit, which also known as detector circuit. Next, impacts of carrier frequency and phase error. When there is a phase or frequency difference between the generated carrier frequency and input signal, it will lead to distortion during the modulation process of AM double sideband suppressed carrier signal. And then the last but not least is the super heterodyne receiver. We use in commercial AM or FM radio. This device performs the modulated signal frequency translation known as frequency mixer. We use high frequency to shorten the wavelength. Why? So the advantages is to overcome weakness in the component that could not operate at high frequency. Component operate at fixed frequency will optimize its usage and reduce cost. So we continue with FM.
Modulation, which consists of frequency modulation and also phase modulation. Frequency modulation is a method used to encode information in a carrier wave by varying its frequency. In simpler terms, it's like changing the pitch of a musical note to convey different signals. In frequency modulation, a similar principle applies to radio waves. The carrier wave's frequency is modified according to the variations in the input signal, just like your voice or a music track. So, if you were to translate this to a practical example, think of tuning in to different radio stations. Next, these are the basic steps involved in frequency modulation. First is the generation of carrier waves as shown here, and the next will be an audio input, which is the information source as shown over here. Next, the audio signal is modulated onto the carrier wave using a frequency modulator as shown here. Higher frequency for higher amplitude in audio signal. Next, the signal is then modulated and then transmitted over the airwaves using this antenna over here. The signal is then received by radio, for example, and then we can tune it to different frequency to change to different channels of the radio. Inside the radio, there is this component called filter, which used to obtain particular frequencies so that we can tune in to different radio signals. This process is called demodulation and receiving. it. The final steps consist of recreation of the original audio signal. Phase modulation is also another type of modulation. It is encoding information in a radio wave by adjusting the starting point or phase of the wave. It's like altering the initial position of a spinning top to communicate different messages.
So we go to the next modulations, which is radio digital modulations. Telecommunications networks are changing towards the digital world. Therefore, signals must be changed to digital form so that they can be transmitted through this network. So, to keep the digital signal to transmitted, we must change first the digital signal into the analog carrier signal. So that's why we call it as. So to change the data to the modulate the data, we have three techniques that can be used, which is ASK amplitude shifting, FSK frequency shifting, phase shifting, which is PSK. So this is three, which is amplitude, frequency, and phase. It will just change the three things. So I will explain a bit, which is amplitude shifting, ASK. The modulating digital signals are change the amplitude. So you can see the amplitude is changing by how it represent the bits. For the one, you can see one here. The amplitude is 1, for example, and the 0 is no amplitude. And for frequency shifting, we can see how it represent the bit 1 in the diagram. The bit 1 is much higher frequency, which means when the higher frequency, the time is shortened. So the last is phase shifting. So the phase shifting is different between just now. The phase shifting, you can see the phase is changing when there is 1. You can see there is double 1 here, and the phase changing 2 times. That means there are 2 to 1, and so on. So this is for 1 bit. What about 2 bits and above? So more than 1 bit, you will use multi-level shifting. So for represent 1 bit, we can represent by a symbol, which is symbol is equal to 2 power of n, where n is the bit. So for symbol rate is equal to baud rate, which is equal to bit rate over n. So this is applicable to all that we learned just now, which is ASK, FSK, and PSK. But for the PSK, this has been proven to be the most useful. So we learn about a bit about PSK, multi-level PSK, which is quadrature phase shifting, QPSK. So one symbol represents 2 bits. You can see 2 bits is 00, 01, 10, and 11, which is shown in grey code. From the diagram, we can see the difference between the PSK that we learned just now. We can see PSK, the phase shift is 180 degrees. But for this one, quadrature phase shift keying, QPSK, we can see it will shift differently, depend on the bits or depend on the symbol. Which is for 45 degrees is for 11, and 135 degrees for 01, and so on.
Hi, I'm Lau. Now let's talk about the recent advancement in the communication field, which is the 5G technology. Later we'll be discussing on how 5G is different from 4G and what normal misconceptions do people usually have towards 5G. First, how does 5G differ from 4G? In a positive way, 5G provides way faster internet speed in gigabytes per second, enabling quicker downloads, smoother streaming, and overall improved internet performance. Besides, 5G have low latency, which supports applications like AR, VR, autonomous vehicle, remote surgery, real-time communication, and many more, enhancing user experiences. Other than that, 5G have enhanced connectivity with higher capacity and speed, enable a greater density of connected devices, which is crucial for IoT growth in home, cities, industries, and healthcare. In contrast, 5G technology also increase privacy and security risks. The increased connectivity and data exchange in the 5G environment raise privacy and security concerns. A vast amount of data generated by IoT devices could be vulnerable to hacking or unauthorized access, leading to potential breaches of privacy. Next, the infrastructure costs will increase, which means we need to pay more for our internet. The rollout of 5G requires significant investment in new infrastructure, including small cells and other network equipment. The costs associated with this deployment may be passed down to the consumer, leading to increased internet service fees. In addition, 5G will create environmental impact. The manufacturing, installation, and maintenance of 5G infrastructure will contribute to electronic waste and energy consumption. Now, let's look at how normally people perceive 5G wrongly. Some people may think that all 5G networks around the world are the same, but actually there are different frequencies and bands within the 5G spectrum, including low band, mid band, and high band. Each one has its own characteristic, and the performance of 5G network can vary depending on the frequency used. So, in different locations, different frequencies is used, and different 5G networks produced. Besides, some people may think that all 5G devices are compatible everywhere around the world. 5G network operate on different frequency bands worldwide, as we mentioned just now, leading to variations in compatibility. So not all 5G devices are compatible with all 5G networks, and regional differences in frequency allocation can affect the device performance. Also, some people may think that 5G poses significant health risks. They express concern that 5G technology poses substantial health risks due to increased exposure to electromagnetic radiation. However, scientific consensus, based on extensive research, suggests that 5G technology when implemented within the regulatory limits does not pose notable health risks to humans.